Welcome to Module 3 of our Power BI training course, From Puny to Peerless. This course is designed to take you from a complete beginner to an advanced Power BI user, helping you harness the full potential of the software. This course will equip you with the necessary skills. Let's dive into the world of Power BI and begin our journey. Throughout this module, we will cover essential topics to help in understanding relationships, one-to-many and many-to-many, and their role in data modeling, building data models with relationships and managing cardinality, introduction to star and snowflake schemas for data optimization, and we will have a practice task to create a data model using a multi-table sales dataset. We will also follow the instructional format by answering these key questions. What is it, or what are they? How does it, or do they, work? Why is it, or are they, important? How can I, or we, use it? Real-world examples, key takeaways, and finally, practice task and solution. What's data modeling? Data modeling is the process of organizing and structuring data by defining relationships between tables to support efficient analysis and reporting. In Power BI, a data model connects facts, quantitative data, with dimensions, descriptive data. Its types of relationships include one-to-many. One record in a table links to many records in another table, for example, customer to orders, and many-to-many. Multiple records in both tables can relate to each other. For example, products to promotions. How does it work? Relationships are defined by key fields, such as customer ID or product ID. Power BI uses these relationships to automatically filter and aggregate data across tables. Building data models with relationships and cardinality. What is it? A relationship defines how two tables are connected, while cardinality describes the number of matching records between those tables. Why is it important? Defining relationships correctly ensures that filters, aggregations, and calculations behave as expected in reports and dashboards. How does it work? In Power BI, you can define relationships in the model view, and cardinality can be one of the following. One-to-many. Example, one customer can place many orders. Customer ID, customers. Exchange customer ID, orders. Many-to-many. Example, a product may appear in multiple promotions and a promotion may apply to multiple products. One-to-one. Example, one employee is assigned to one employee profile. Now with an example for how to create a relationship. Tables, customers, customer ID, customer name and region. Orders, order ID, customer ID, order, date and total amount. Relationship, customer ID, customers. Exchange, customer ID, orders. Steps. First, open model, view in Power BI. Then, drag customer ID from the customers table to customer ID in the orders table. Finally, set the relationship type to one-to-many. Star and Snowflake schema basics. What is it? A schema defines how tables are structured and related in a data model. Common schema types include star schema, the central fact table. For example, sales, surrounded by dimension tables. For example, customers and products. It is simple and optimized for performance. And Snowflake schema, where dimension tables are normalized, split into multiple related tables. It is more complex but supports detailed data structures. Why is it important? Schemas improve query performance and data readability. Star schemas are often preferred in Power BI for their simplicity and efficiency. How does it work? In a star schema, all dimension tables directly connect to the fact table, while in a snowflake schema, dimensions are further divided into subdimensions. Example: star schema for sales analysis, fact table, sales, columns, sale ID, customer ID, product ID, sale date, and sale amount. As for dimension tables, customers, customer ID, customer name, and region. Products, product ID, product name, and category. Dates, sale date, year, month, and day. Real-world examples. Scenario 1. Sales dashboard. A retail company builds a star schema with sales as the fact table and dimensions for customers, products, and regions. This enables them to quickly analyze sales trends by product category and region. Scenario 2. Employee performance analysis. An HR department uses a snowflake schema to analyze employee performance. The fact table stores performance scores, while dimension tables include employees, departments, and training programs. Scenario 3. Marketing campaigns. A marketing team defines a many-to-many relationship between products and promotions to track campaign effectiveness across multiple product lines. Here are some key takeaways from this module. Data modeling defines relationships between tables to support efficient analysis. Relationships can be one-to-many, many-to-many, or one-to-one, with cardinality describing how records match. Star schemas provide simple, optimized structures for analysis, while snowflake schemas support more complex data structures. And real-world applications include sales analysis, employee performance, and marketing campaigns. Let's reinforce what we've learned with a hands-on exercise. Practice task. Create a data model. Task instructions. First, download and connect to the sales data and customer data datasets. Second, define relationships between the following tables. Sales contains sales transactions. Customers contains customer details. And products contains product details. Then, create a star schema by linking the sales table to customers and products. And finally, add a calculated column to the sales table for total sales amount. Quantity times price per unit. Solution steps. First, connect to the datasets. Click Get Data, then text, CSV. Select and load the sales data.csv and customer data.csv files. Then, define relationships. In Model View, drag customer ID from the customers table to customer ID in the sales table. Drag product ID from the products table to product ID in the sales table. Finally, add a calculated column. In the sales table, add a column with the formula DAX. Copy edit. Total sales amount equals sales quantity times sales price per unit. The expected result is that the data model should reflect a star schema, allowing users to analyze total sales by customer and product. That brings us to the end of this module. Remember, mastering Power BI is a journey, and every step you take will bring you closer to becoming proficient. Stay curious, keep practicing, and I'll see you in the next module as we continue our Power BI adventure. You've got this.